So in today's revision class, we will discuss these topics, that is interfaces, polymorphism, inheritance, and software lifecycle. So we will start from beginning. And as you know that your first topic was interface. So we will discuss them one by one, and I'll try my best to cover all the topics which I covered before midterm and also after midterm. Now first is interface. And as you know that in case of interface, all methods defined in the interface type have three properties. The first property is all methods are abstract. Abstract methods we use in interface. So can you tell me what do you mean by abstract method? Yes, very good. It means that they are declared but they are not defined. There is no implementation detail of it. As you can see in this program, we have interface called animal. And inside this animal interface, we have two methods, that is eat and travel. So you can see over here, we have declared these methods, but there is no definition of this method inside this interface called animal, isn't it? So methods are only declared and they are not defined in case of interface. Now second property is that all methods are public in nature. So even if you are not declaring it public, still the methods will be considered as public. So this thing you have to remember, that in case of interface, methods are neither private they are not protected. So three types of methods we have: public, private, and protected. So all methods are public in nature. They are neither private nor protected. So either you can use public keyword over here. Even if you are not using public keyword, still these methods will be considered as public and your program will not give any error. And finally, the third and most important property is they do not have instance variables. Now when we talk about instance variable, okay, so as you know that object stores its data in instance variables. So data is basically stored inside instance variables. So an instance of a class is an object of the class. Thus an instance variable is a storage location that is present in each object. So if anyone asks you that what is an instance variable, you will say that an instance variable is a place where object stores its data. Yes, Miss Amal has also joined our session. So now 3 students are there, and only these 3 students are always there in my virtual class. I'm really happy with all of you, really. And I'm really disappointed with other students. So can you tell me what do you mean by instance variable? How you will define instance variable? Place that the data is stored in it. Okay. So you can define it as an instance variable is a storage location that is present in each object and where an object stores its data. Yes. Okay, so this is proper definition of instance variable. So this program is based on interface, and now you can find out that interface merely specifies the behavior that an implementing class should supply, and it provides no implementation. In contrast, a superclass provides some implementation that a subclass inherits. So next is polymorphism. This is our next topic. So what do you mean by polymorphism? Yes, these are two types of polymorphism techniques, overloading and overriding. That's good. But if someone asks you what is polymorphism, what will be your answer? Okay, poly means many. How to treat the object? Okay, good. See, poly means many, okay, many, but not subclass. You cannot say many subclass. Rather, you can say many forms, because morphism means forms. Okay, so it's better to say many forms. Polymorphism means many forms. And how to treat the object? Yes, it is good. Yeah, you are correct that polymorphism denotes the ability to treat objects with differences in behavior in a uniform way, as you can see in this definition. So they are different objects and they have different behavior. So polymorphism allows to use these objects who have different behavior in a uniform way. And there are two techniques in this polymorphism, as you have specified. It's absolutely correct. We have overloading and overriding. And there is one program which is based on polymorphism over here. If you will go through this program, you will find out that we have created a class called virtual demo, and inside this class we have a salary. We have created an instance variable for salary and an instance variable for employee, and then we are calling a method which is defined inside salary reference class, and another method which is defined inside employee reference class. And finally, this is the output. Even if you will go through this program, we have mail check method over here, and we have get name method, and here we are extending the employee class. So again we have mail check method, As you can see, already we have mail check method, but we have another method in salary class also, which is all defined by the same name, and we have set salary method. Now here what we are doing, we are calling the mail check method of salary reference. Okay, and we are calling the mail check method using employee reference. But what will happen, even if this method is there inside employee class, but the same method is being called again twice. So this program is based on overloading, which is one of the most important property of polymorphism. You remember this program? You remember this program? Main method. Yes, this is main method. This is main method. So inside main method, we have created instance variable of two classes, that is salary class and employee class. And we try to call this method, mail check method, which is there in both the classes, in salary class also and in employee class also. But when you will run this program, since it is based on polymorphism, so what will happen, even though you have used e.mailcheck, you are calling mail check method or employee class, but still it will call the mail check method of salary class. We have discussed this programming example before. I have uploaded it on Blackboard also. Have you tried it? Is it clear? Inside the class. Yes, inside class. You see, here we have a class called virtual demo. And inside this class we have main method. This is not interface, Ms. Fatima. This is based on polymorphism. Here there is no interface. This program is based on polymorphism. Okay. Is there any interface class here? Have we defined any interface? No, isn't it? Yes. So there is no interface. So it is not based on interface. If you want to see the program of interface, okay, here you can see we have used interface animal. So this is an interface animal. Here there is no interface. Here just we have a subclass, we have superclass, we have declared two methods by same name, and then we have created instance variable, and we are calling the methods of these classes. But since it is based on polymorphism, so what will happen? The mail check method of employee class will not be called. Instead, the mail check method of salary class will be called twice. because you can see this definition. Polymorphism denotes the ability to treat objects with differences in behavior in a uniform way. This is the definition of polymorphism, means it has multiple forms. Is it clear? Yes, Ms. Fatima, you have any problems? Or it's clear? Yes, Ms. Amal, it's clear, that's good. What about, but we forget the code because it was not required in midterm. Okay, if you want to revise it, do one thing. I have uploaded all programming examples on Blackboard. Okay, so go to your Blackboard and there is a folder named as programming examples. Okay, in programming examples folder, you will find this program. So try to run this program on your PC and you will find out how it works. Okay. Now next is inheritance. So in inheritance, you know that we have a superclass, which is also known as parent class, and we have a subclass called child class. So superclasses are basically the generalized classes, and subclasses are also known as specialized classes. So when we are talking about generalized classes, they are close to root, and when we are talking about specialized classes, they are close to branches. Okay? Yes. So here we have an example. We have a parent class, we have child class, and you know that child class inherit the property of parent class in addition to having its own property. So here we will see that child class inherit the property of its parent class. So whenever you are using inheritance, you have to use this keyword called extends. This is important. And whenever you are using interface, you have to use keyword. Which keyword you have to use? Yes, good. Implements. Yes, implements. Now, there are some symbols which shows relationships between classes. So if you have to show inheritance relationship, you will use a straight line and then a triangle at the top. So you have to use this symbol in order to show inheritance. So if suppose we have two blocks, okay, we have two blocks suppose, and you have this symbol between these two blocks. So it will show that this is inheritance relationship. Similarly, if you want to show interface implementation, in that case, use dotted line. You have to use dotted line and a triangle at the top. So it will show interface relationship. In order to show aggregation, you have to use a straight line and a diamond box at the top. So this is a diamond box at the top. This shows aggregation relationship. And in order to show dependency, use dotted line and an open arrowhead. So here you have an open arrowhead and a dotted line to show dependency relationships. So these are four types of relationships and their corresponding symbols. So you have to remember these symbols. And when we go in detail, we will find out that there are two types of relationships in inheritance. One is known as is-a relationship and another is known as has-a relationship. So this is an example. Yes. This is an example. Is-a relationship and has-a relationship. So If you see this example, we have a class called car. This is a generalized class because this is parent class. So this is generalized class. And we have two specialized classes, that is Maruti and engine. So the relationship between the specialized classes has a relationship, and the relationship between generalized and specialized class is a relationship. This is clear? Okay, good. Yes, Miss Aisha, are you with me? Is it clear to you? Miss Amal, you have any problem? You have raised your hand. You want to ask something? Yes, okay. Tell me. I am waiting for your query. Yes, Miss Aisha, are you with me? I have some problem with net. Okay, there is some internet problem your side. No problem. This session is recorded, so you later on also you can hear it. Now next is software life cycle. So whenever you have to develop any software, you have to follow some steps. So when you see the development process of software, you will see that there are basically 5 steps. There are 5 steps. First is known as analysis phase. Second is design, implementation, testing, and deployment. These are 5 phases in software life cycle. Now during analysis phase, you have to decide what is the object of your project. So you have to think about its requirement. And you need not to think about the program or coding. Don't think about program at this stage. Just think about the requirement of your project. So the output of this phase will be a requirement document. And that requirement document will contain these 3 important things. First one is the description of what program will do once it is completed. So it's a description in the form of plain English language. Secondly, a manual which will tell the user how to operate the program. And finally, the performance criteria. So these are the 3 outputs that will be there in requirement document. So it's in plain English language. There is no coding, no technical terms, nothing. So once analysis phase is completed, the next phase is design phase. During this phase, you have to plan how to implement the system. So here you have to discover the structure. What will be the structure of your software? And you have to decide classes and methods. Still, you need not to think about coding. Don't think about coding at this stage. Just think about structure, classes, and methods. And the output of this phase will be a description of classes and methods. So it will be in plain English language. And next, the diagrams, which will show the relationship among classes. So you know how to represent relationships. We have seen that in previous diagram, that in order to show relationships, we have these symbols. So in your software, if you have inheritance relationship, you have to use this symbol. Interface relationship, then you have to use this symbol. So you have to deliver a report which will specify the classes and methods, and also the diagrams which show the relationship among classes. Is it clear? Okay. Miss Aisha, I'm not getting any response from your side. Are you with me? Okay, I think we should continue. Now next step is implementation phase. Now here you have to think about coding. You have to think about code. So if you are using C++ platform, you have to write your code by using C++ programming language. If you are working on Java, you have to write your code in Java programming language. Similarly, in .NET or whatever programming language you are using, in whichever platform you are working, you have to write and compile your code in that programming language. And next is, this code will implement the classes and methods. So these classes and methods you have already identified in design phase. So as you can see here, you have decided the classes and methods. So now these classes and methods will be implemented during implementation phase. And finally, the output of this phase will be a completed program. Okay? Completed program, which you can compile and run. Now next is testing phase. During this testing phase, you will give some input to your program, and you will test your program according to that input. So during this phase, you have to run tests to verify that the program is working correctly or not. And the output of your phase will be a report, which will consist of test samples, means with the input that you have given. You will mention the inputs and their corresponding result, the corresponding output you will mention in that report, that when you have given this input, the output was this. And if there is any exception, you have to mention those exceptions also, that when we have given this input, the output was an infinite loop. So you have to mention exceptions also during testing phase. And finally, during deployment, the software is given to the end user, and the user will install that program and they will start using it. Now there is another phase which is known as maintenance phase, which is known as maintenance. But this does not come under the software life cycle, but this is also an important phase, maintenance. What happens in maintenance? This phase does not come under software life cycle, so don't get confused with it. This phase is used when the software is deployed, means it is given to the end user, they are using it, and when they report some error, so what happens, it is returned back to the development team and they will correct those errors. So that is known as maintenance phase. Yes, exactly. If there is a problem, we have to correct it. So that is a maintenance phase. And then again, the software is deployed to the end user. So this phase does not come under software life cycle. Software life cycle has only 5 phases: analysis, design, implementation, testing, and deployment. Yes, only 5. But this is 6th phase, that is maintenance phase, and it does not come under software life cycle. So this thing you have to remember. Now, during software development, you will use some models. One such model is waterfall model. As you can see in this diagram, it's like a waterfall. It starts from top and it will move downwards like a waterfall. So it's a sequential model. It is a sequential model where you have analysis phase, design, implementation, testing, and deployment. And the output of this phase acts as an input for another phase. As you can see over here, the output of one phase is dependent on another phase. Okay. So this model is purely sequential, and when rigidly applied, it does not work because it has some disadvantages also. Since we have to wait, if we are in design phase, then we have to wait until and unless analysis phase is complete. Then once analysis phase is complete, then only we can start our design phase, and so on. If we are in implementation phase, we have to wait until and unless design phase is complete. Okay, so this is completely sequential. So there is lot of wastage of time and money in this model. And also the problem is, if there is any error in between, or you have to make any correction, you have to start from beginning. So the another model that we have followed is known as spiral model, in which the disadvantages of waterfall model are removed. So here what we have break the development process into multiple phases. We have, and early phases focus on the construction of prototypes. So here in a spiral model we create prototype. What do you mean by prototype? Label in production. Okay. Anything else? Yes, Miss Amal, you have raised your hand. You want to say something? You can use your mic. Yes, Miss Michelle, what do you mean by prototype? You can't see it? You can't see these slides? Really? No. What about others? Can you see these slides? Is it visible to you? Yes. Okay. Miss Amal, check your connection. Okay. I think there is some problem your side. Yes. Because other students can see it. There's no problem with them. So I think there is some problem your side. You have to check it. Okay. So what do you mean by prototype? Prototype means the label that we can test the project at 1 cycle. Okay. Prototype means exact replica of original software. It's an exact replica. It's a copy. Replica means copy. Okay. It's a copy of original software. Okay. And finally, in this model, the lessons learned from development of one prototype can be applied to next iteration. That means if there is any error, once you will follow all the steps, okay, and you receive one prototype, and if there is any error, you will give end user to use it. The end user will use and they will report errors. And if there is some error, that error is recovered, that error is removed in next iteration, in next prototype. So you can see the diagram of a spiral model. Your development process starts from here. This is analysis phase. So once analysis phase is complete, the next phase is design phase, then implementation, then you have testing, and then you have deployment phase. So once this phase is complete, you get a prototype. You can see here you get prototype 1. Now this prototype is given to the end user. They will use it, and if there is any error, that error is recovered. The error is completely eliminated, removed in next cycle. So again, next cycle will begin. This is our second cycle. So here we have analysis phase, then design, implementation, testing, and deployment. And once this phase is complete, we get second prototype. Again, this prototype is given to the end user. And then next phase starts, which again follow same steps as you can see over here. And you will get the final product. So the problems that we were facing in waterfall model, they are eliminated in a spiral model, but the disadvantage of this model is it leads to, yes, you can go back, exactly. This is the advantage. But the problem is it leads to many iterations, as you can see in this diagram. How many iterations are there? How many iterations? Yes, good. 3 iterations are there. Now, if the project is a big one, if we have a very big project, then what will happen? What do you think? Are 3 iterations sufficient? Yes, you need more iterations. If the software is, if you have a big project, if you have to develop a rigid software, then in that case, number of iterations will be more. So it leads to many iterations, and the process can take too long to complete. So this is a problem which is there with the spiral model, but still, as you can see, there are many advantages also. So these problems can be neglected. So this was all about interfaces, polymorphism, inheritance, and software lifecycle. If you have any question, you may ask. Yes, next week also we have our virtual class, and I'll try my level best to complete all the topics that has been discussed so far. So I will try my best, inshallah. I will cover them. Or if you want clarification in any particular topic, you can let me know. If any topic is not clear to you, you want more clarification in any particular topic, then you can tell me. I will discuss it first, and then I will cover rest. Write the program from the examples. Yes, so these programs are there on your Blackboard. Okay, just download those programs, those examples, and try to run it on your PC. Okay, all examples I have uploaded on Blackboard. Okay, all topics are clear to you that we have discussed till week 13. All topics, searching, sorting, then we have discussed trees, binary tree, binary search tree, pre-order, post-order, in-order traversal, heap sort. Do you want clarification? Is there any word? Yes, next week we have virtual class. Yes, one more virtual class is there. All topics are clear to you, or you want clarification in any particular topic? If it is, then let me know. Okay, start doing your revision. You have your exams are approaching. We are quite near now. And if you have any problem, you can mail me anytime, okay, regarding any topic. And all the very best for your exams. Prepare well. And inshallah, we will meet next week. Till then, take care, all of you. Assalamu alaikum.